Good morning, statistics students. Just wanted to touch base and get the week started on the right foot. We are going back to Sapling Learning assignments. So you'll be getting your assignments from Sapling this week. I will inform you, let you know on Google Classroom as well, but you'll be going to the Sapling site to do that homework, and that's where I will see that you have completed it. You'll have 3 assignments this week. They will all be due to Thursday night. And so I'll let you work at your own pace and how you go about that. I'm going to introduce you to the first section today, and you're going to see that it's very similar. In fact, the entire chapter is very similar to last chapter. And you're going to see a lot of the same ideas. And I'm going to show you that today. You're going to need to use your calculator a fair amount. But in general, just the main idea is that you're comparing 2 sets of sample data and seeing if they're different or the same in some way or another. So we have some similar requirements and different ways to go about these problems. We will have 3 types of problems, very similar to what we did last chapter, but we will progress a little bit faster than last chapter. We won't have quite as much review, so just be aware of that. I just wanted to show you all how you guys performed on the test. Most of you got your individual scores, but as a class, half of you got an A. 57 people took the test, 29 got A's, 49 out of the 57 got an A or B. So that was very good, outstanding work. Some of you have trouble following directions. When I ask you to do the answers on the answer sheet, that would be really, really helpful. Then I don't have to flip through pages on the computer. That takes time. And so if you just put it on the answer sheet, that would be really, really helpful. And then if you would also make sure your pictures are vertical, that would really help. So keep that in mind. Whenever I do a review worksheet or a quiz or a test, try to keep your orientation vertical, and then I will be making up answer sheets for each of those, so it's easier for me to grade and look at your work. All right, so let's get into today's assignment. Okay, so this chapter 9, as I had said, deals with comparing 2 sets of data. The first one is going to be comparing proportions. That's the first 2 sections. The first section is going to be dealing with describing the shape and center and variability of the sampling distribution. We're going to also check for random and large counts conditions being met so that we can construct an interval. And then we are going to actually construct intervals. In the second section, we will check for conditions, and then we will do a significance test and looking at whether the p-value is going to be less than our significance value. So the same guidelines or same structure to all of that will be, we'll look at that tomorrow, and it'll be the same kind of thing. Check for conditions, what kind of test is it, then the hypotheses, the critical value, the test statistic, the p-value, the interval, your conclusions. All of that will be making up some of these problems. Now, when you do them in the sampling, they don't do it in that same manner. They do it in pieces. So just be aware of that and how they do that. I'm going to try to show you all of this in like one problem, and then in the homework it'll be pieced, and hopefully you'll be able to connect that. You can always refer back to the Sapling videos and other things that are here. So let's go ahead and get into a problem. So here's a problem. To explore the sampling distribution of P1 minus P2, let's start with two populations, and the two populations are two different schools. At school one, 70% of the students did their homework last night, and at school two, 50% of them did their homework. The counselor at school one takes a simple random sample of 100 students and records the proportion who did their homework, and school two takes a simple random sample of 200 and records the proportion of students. And so here's the information that we have from the 100 and the 200. The first set of samples give us 72% and 47% for proportion 2. So if we were just going to describe the difference, we would expect the difference to be 72% minus 47. That would be the mean of the difference, okay, the mean of the differences. So that's why it falls there. Normally, we would expect it to be 20%. Now, how did they get that? They got that from going 70 minus 20. So would this sample be expected in this case? Yes, it would be, because it falls here in the fatter part of the graph. It's a fairly likely situation if we were to repeat that a bunch of times. So it suggests that we have a approximately normal shape. Now, again, if you calculate the mean, it's just simply 0.7 minus 0.5 to get the 0.2. Now, the one part that's really a little bit challenging is the standard deviation. And here's the formula for the standard deviation. You're going to multiply P1 times 1 minus P1 divided by the sample size plus, and then all of that's going to be square rooted. So if you look at these numbers, these are the numbers from the original set of data that they estimated. So there's the formula, and you need to make sure you have that available to you. And when we do take quiz and test, you will be able to have this. You will not have to memorize this. So you can have that with you, write it down on a sheet so you can remember that. That's not something that we expect you to memorize. So what's it look like? Let's look at a problem. So here we have a problem. Angelica and Kyle live in two different states, and they work for the DMV. Angelica's state has 84% of the registered cars made in the US, and Kyle's state has 63% of them. Angelica selects a sample of 100 cars. In her state, Kyle selects 70. Let P1 minus P2 be the difference between those two. So what is the sampling, or what's the shape of the sampling and why? So it's approximately normal. And the reason why it would be approximately normal is because at 84% of 100 cars, you would have 84 that are made in the US and 16 that were not. For Kyle's state at 63%, both 63% and 37% of 70 are more than 10. So all four of the situations meet the large counts, and you have to have that. And so that's why this would be considered approximately normally distributed. So because the large counts are met. Now find the mean of that sampling distribution. It would be where to go, 84 minus the 63, which would just simply give you 0.21. So here they show you the work for approximately normal because they meet all of those conditions. And then part B, there's the mean of the differences between those proportions. So remember, we're talking about the mean of the differences, not the mean of each sample. We're talking about the mean of the differences of them. So the mean would be 0.21. And then the standard deviation, you would put the information into that formula. So 0.84 times 0.16 divided by 100 plus 0.63 times 0.37 divided by 70. And all of that taking the square root of it, and it comes out to about 0.068. So what does that mean? Well, that means that when we take similar samples of this, we would expect them to be about, I'm going to round this to about 7%, within 7% of 0.21. So what's that mean? That means I'd have a range from about 14% to about 28%. That would be kind of the expected range of all the outcomes in those samples. So that's very similar to some of the previous things that we've talked about. Don't forget to refer back to this. You're going to have problems where you have to determine whether it's approximately normal or not based on meeting the large counts requirement. And then you're going to have to find the mean of the differences, the standard deviation of the differences. So that's the first probably 2/3 of your assignment. The last portion of it is going to be estimating the interval. So the interval of the differences. And so again, we have our same two requirements for being able to do that. You always remember we have to have random samples, and then they have to meet the large counts, which we've already talked about. So I'm going to skip all the way down to the last example that they give. And I want to show you this, if I can get there. Okay, so how much did President Obama's approval rating change? So someone selected some information between 2012 and 2014, and they described the situation. Well, first of all, we have to figure out, do they meet the requirements? Well, if I have 780 that approved, that means I have 720 that didn't. So certainly those are bigger than 10. And then in the 2014, there was 615 that approved. And so obviously those numbers are larger than the 10 that we need. So we certainly can do that. So now it says we want to estimate the interval here, construct and interpret the 90% confidence interval. So I want to show you on the calculator. If you look at the book, they will show you the formula way, and I think you'll find it quite a bit easier to use the calculator. So hopefully I can, wow. I have to remember two numbers, 615. I'm going to write that over, oops, out of 1500. That was 2014, 2012. Let's see, we have 780 out of 1500. So again, let me go to the calculator now since I have my numbers there. So in your calculator, you're going to go to stat and tests where we've been going. Now remember, we're doing a 2 proportion Z interval. So I'm going to scroll to the second page, and it's alpha B. And now X1 is the year, what do they tell us? They define 2014 as the P1. So you have to be careful about that. We're using this as P1, even though they gave us that as the first. They want us to compare that. They want to know how much it's changed from there. So I'm going to put in 615 and then 1500. And then for my P2, it's the 2012, so that would be 780 and then 1500. And then 90% is our confidence level. And oops, I didn't want to add it. So let me go back. I messed up. There, I've put in all my information, and now I need to calculate it. And there it gives me the P1 is 41%, P2 is 52%. So how much did it change? Well, it went down by about somewhere between 14 and 8%. Now, how would I write that? That's an important question. I would tell you to write it like this. Now, here's the part that is different. P1 minus P2, and it falls between 8% and 14%. So that would be constructing that interval. Now let's see if my work is correct as we scroll down. So it talks about that plan to sample. Now here's all the work that they have to go through to do all of that and check for the requirements. So that works. We know that. So then they do all of their work. And so what it comes out to is exactly what we have. It drops by about 14 to 8%. And if you look at this, how do we conclude, or what kind of conclusion can we draw from this? This is the statement. This goes back to chapter 6, I believe, or chapter 7, I should say. So we are 90% confident that the interval of negative 0.14 to negative 0.08 captures the true change in the proportion of all U.S. adults who approve of President Obama's job performance from 2012 to 2014. Okay, so, and you can read the rest of that on your own, but that's where you go in the calculator. I'm not sure that they actually show that in here. I don't remember seeing a tech. Oh, here it is. So yeah, if you scroll all the way past the last example, they'll show you this, and you can go show the applet, and then there's the TIA 83 and 84. So it will give you an explanation as well. So hopefully that information will help you today and get through today's assignment. I will be putting those up and making them available, as I said, all 3 of the assignments, and they will be due Thursday in the evening. All right. Hope you have a good week. Hope all is well. Thank you for your attention to the test last week, and you guys did a good job on that. Thank you very much. Have a good day.